All right, lesson 14, kind of tying everything together, looking at division, looking at graphing, looking at everything put together. Question 1 says we know these things about polynomial function f of x is exactly one relative maximum and one relative minimum. It has exactly 3 zeros. It has known factor of x minus 4. Sketch the graph. Well, I'm going to start piecing this thing together. So if I have a factor of x minus 4, that means I have an x-intercept at 4. So that's going to be my first place that I'm going to take a look at. It has exactly one relative maximum and one relative minimum. That means it goes up and down. And there are exactly 3 zeros. So just to kind of make my life easy, I'm going to kind of spread out those zeros. I'm going to go at 4, 0, and negative 4. And we also know that's about it. It has a maximum and a minimum. It has 3 zeros, and one of those zeros is at 4. It says sketch a graph of f of x given this information. Well, I have really two possibilities because I don't know what the end behavior is. This graph could look something like this, or it could look something like this. Either one of those are perfectly fair game, and to be honest, those other zeros don't need to be where they are either. So lots of different possibilities here. The only thing that for sure needs to be there is this, and then 2 more x-intercepts. Okay. My graph's a polynomial function f of x that has 3 linear factors, but she makes a mistake. What is her mistake? Well, if she's taking a look at this, I should have the zeros of -6, -2, and +1. But if I look at her graph, she has the zeros at 6, 2, and -1. So her zeros are opposite of what they should be. All right. Question 3 says here's the graph of a polynomial function with degree 4. Select all the statements that are true about this function. And we're just going to kind of go through and do a true false with each one. The leading coefficient is positive. Well, because this is a degree 4 polynomial, and I'm looking at this thing, it looks like we have the end behavior that is up, up. If I have the end behavior that's up, up, that means I do have a leading positive coefficient on an even degree polynomial. The constant term is negative. Well, the constant term would correspond to the y-intercept, and in this case, my y-intercept is not negative. C says it has 2 relative maximums. As I'm looking at this graph, a relative maximum means it's a point where it kind of like tops out. And I can clearly see one of these maximums, but I don't see anything else. So there's only one relative maximum. D says it has 4 linear factors. Well, the 4 linear factors correspond to the 4 zeros. And in this case, there are 4 zeros, so that checks out. One of the factors is x minus 1. The factor of x minus 1 would correspond to the 0 of x equals 1. So if I'm looking at my graph, there is nothing right here at x equals 1, which means that's not true. F says one of the zeros is 2. If I do look at my graph, I can see this thing crosses the x-axis right there at 2, which means F checks out. One of the zeros is at x equals 2. G says there's a relative minimum between 1 and 3. So if I were to look at my graph, between the x value of 1 and 3, it says that there is a relative minimum in there. Well, I don't see a relative minimum in there. My only relative minimums are way down here and way down here, which means G is no-go either. All right. Question 4 says state the degree and the end behavior of 2x to the third minus 3x to the fifth minus x squared plus 1. Well, I have to be careful because this thing isn't even in standard form. If I did put this thing in standard form, I would have negative 3x to the fifth plus 2x to the third minus x squared plus 1. The degree is not in descending order, which is why it's kind of easy to make a mistake here. And here I can clearly tell what my leading term is. My leading term is negative 3x to the fifth. Because my leading term is negative 3x to the fifth, I have a leading coefficient that is negative 3, which means my end behavior is getting flipped upside down. The degree is 5, which means my end behavior is not down, up, but up, down. All right. Keep going. Question 5. Is this the graph of g of x is equal to x minus 1 squared times x plus 2, or h of x is equal to x minus 1 times x plus 2 squared? Well, the only thing that's happening here, the difference between these two, is the multiplicity of one of these factors, one of these roots, one of these zeros is 2, and one of them is 1. So I need to look at my graph, and I can tell I'm bouncing at 1, which means I need to have x minus 1 squared. And the only one that has the x minus 1 squared is g of x. So I know that this is g of x because of the bounce. 6 says Kieran thinks he knows one of the linear factors of p of x is equal to x cubed plus x squared minus 17x plus 15. After finding that p of 3 is equal to 0, Kieran suspects that x minus 3 is a factor of p of x. So he sets up a diagram to check. Here's a diagram he made to check his reasoning, but he is set up incorrectly. What went wrong? Well, this one's pretty quick and easy to tell. If we're trying to be dividing out x minus 3, this actually needs to be a negative 3. So he missed the negative sign in front of the 3. And then in return, everything else kind of gets messed up. So that was really his primary mistake. 7 says, the polynomial function b of x is equal to x cubed plus 8x squared plus 5x minus 14 has a known factor of x plus 2. Rewrite it as a product of linear factors. All right, go ahead and rip out some synthetic division for this. Negative 2 up in the corner. 1x cubed, 8x squared, 5x minus 14. Bring down the 1. Negative 2 times 1 is negative 2. 6. Negative 12. That puts us at negative 7. And positive 14, which means my remainder is 0, which is what I'm expecting to see. Which means after I take out x plus 2, I'm left with x squared plus 6x minus 7. Still not linear factors though. I can factor this chunk. The numbers that multiply negative 7 to add to 6 are positive 7 and negative 1. So having this thing completely rewritten in linear factors, b of x is going to be equal to x plus 2 times x plus 7 times x minus 1. And there is lesson 14, in which we kind of put everything together we know about polynomials.